Imagine a machine so powerful it can peer back in time, 13 billion years, to witness the first flickers of light after the Big Bang. This isn't science fiction. This is reality, and its name is the James Webb Space Telescope. Launched in December 2021, this marvel of engineering represents humanity's most ambitious attempt yet to understand the cosmos. But why was it built, and what makes it so different from the telescopes that came before? For decades, the Hubble Space Telescope has gifted us with breathtaking images of galaxies, nebulae, and distant star clusters. Hubble changed the way we see the universe, but even it had limits. Hubble observes primarily in visible and ultraviolet light. That's perfect for seeing the nearby universe, but the earliest galaxies and the faintest whispers of light from the dawn of time are cloaked in infrared, hidden behind cosmic dust and stretching from billions of years of expansion. Enter James Webb, designed specifically to detect that hidden light. This telescope is enormous. Its primary mirror is 6.5 meters wide, over twice the diameter of Hubble's, and made from 18 hexagonal gold-coated segments, each polished to near perfection. Gold isn't just for luxury, it's the ideal material to reflect infrared light with minimal loss. James Webb also drifts far from Earth, positioned at the second Lagrange point, 1.5 million kilometers away, a place of perfect stability, far from the heat of our planet and its atmosphere that could interfere with its delicate instruments. Its sun shield, roughly the size of a tennis court, keeps its instruments cooled to near absolute zero, allowing it to detect the faintest glimmers of ancient starlight. Why go through all this trouble? Because the earliest chapters of the universe have remained frustratingly elusive. Astronomers have long theorized about the cosmic dawn, the era when the first stars ignited and galaxies formed. Hubble gave hints. We saw the faint outlines of galaxies from 13 billion years ago, but never in full detail. James Webb was built to answer the questions Hubble could not. How did the first galaxies evolve? How did the earliest stars die and scatter the elements that would one day form planets, and eventually life? The telescope itself is a symphony of precision and patience. It took decades to design, build, and launch. Thousands of engineers, scientists, and technicians from NASA, the European Space Agency, and the Canadian Space Agency contributed to this effort. Every bolt, every mirror segment, every instrument had to survive the harsh conditions of space and work in perfect harmony once deployed. One misalignment could render it useless. Yet, against all odds, the telescope unfurled its mirrors and sun shield flawlessly, a mechanical ballet that held the world's breath. James Webb isn't just bigger or farther than Hubble. It's a new kind of eye on the universe. Its infrared sensors allow it to look through cosmic dust clouds, revealing the birthplaces of stars and planets. It can detect the chemical fingerprints of distant exoplanet atmospheres, hinting at the possibility of life beyond Earth. It can even identify supernovae so ancient that the light reaching us today began its journey billions of years ago, long before our sun existed. And now, after just a few years in operation, it has done something astonishing. Among its many discoveries, it has captured the light of a supernova so ancient it challenges our understanding of cosmic history. A single star's death, frozen in time, now has the power to rewrite everything we thought we knew about how the universe evolved. But what exactly did James Webb see? How can the death of one star change our understanding of the cosmos? And why does this discovery matter not just to scientists, but to anyone looking up at the night sky and wondering about their place in the universe? The answers lie in the depths of space, where time itself seems to bend. Have you ever stared at the night sky and wondered what existed before the stars you can see were even born? James Webb doesn't just look at stars, it reaches back to the very infancy of the universe, to a time when light itself was struggling to escape the darkness. It sees farther than any human-made eye before it, capturing the universe as it was billions of years ago. This is not just observation, it is a voyage through time. Unlike Hubble, which observes mostly visible light, Webb excels in infrared vision. Infrared light is like a secret code that carries the story of the cosmos through vast stretches of dust and time. As the universe expands, the light from distant galaxies stretches, becoming redder. Webb's infrared sensors are tuned precisely to detect that stretched light. In other words, what Hubble sees as faint shadows, Webb can reveal as intricate structures, glowing in detail for the first time. Its deep field images are revolutionary. In just a single frame, Webb can capture thousands of galaxies, some of them so distant that their light began its journey when the universe was less than a billion years old. Imagine this. Each tiny point of light is not just a star, but a massive collection of stars, planets, and cosmic dust, all forming in a time when the universe was a fraction of its current age. These images are not just photographs, they are windows into the earliest chapters of existence. The telescope's instruments, NIR-CAM, MIRI, NIR-SPEC, work together to dissect the light of these galaxies. They reveal not only the shapes and sizes of these early galaxies, but also their chemical compositions. Webb can detect the glow of oxygen, carbon, and hydrogen, elements that will one day form planets, and perhaps even life. This is how the telescope turns raw light into a story, letting astronomers read the history of star formation, galaxy mergers, and cosmic evolution. But it's not just about looking back. James Webb also peers into the hidden corners of our own galaxy. Dense clouds of gas and dust, previously opaque to Hubble, now reveal newborn stars, protoplanetary disks, and the chaotic processes of starbirth. We can watch, in real time, the environments that eventually give rise to planets like Earth. For the first time, the telescope gives humanity a front-row seat to creation itself, both near and far. And then there are the supernovae, the explosive deaths of massive stars. These cosmic detonations scatter the elements needed to form planets and life across the universe. Webb can detect them even when they occurred billions of years ago, offering clues about how the universe enriched itself with the building blocks of matter. Among these discoveries, one particular supernova stood out, not just for its brightness, but for its age. It is so ancient, it defies the conventional timeline of cosmic evolution. Every image Webb sends back challenges assumptions, revealing galaxies that appear older and more developed than our models predicted. Some galaxies, unexpectedly massive for their age, force scientists to rethink how quickly stars and galaxies formed in the early universe. This is the promise of Webb. It doesn't just show us the universe as it is, it shows us the universe as it was, in all its formative chaos. And now, as we focus on this ancient supernova, one question looms large. How can a single star, exploding billions of years ago, reshape the story of the cosmos? What secrets does it hold about the first generations of stars, and about the very fabric of space and time? The answers are both thrilling and unsettling, and they are waiting for us in the next revelation. In a quiet corner of the universe, a star exploded. But this wasn't just any supernova. This was a cosmic relic, a star that lived and died when the universe was still in its infancy. Its light has traveled over 13 billion years, crossing unimaginable distances, finally reaching the lenses of the James Webb Space Telescope. And what it revealed stunned astronomers. Supernovae are more than spectacular fireworks. They are the universe's way of recycling matter, seeding galaxies with the elements necessary for planets, life, and everything we see today. But this particular supernova isn't just ancient, it's a puzzle. Its age suggests it formed earlier than scientists thought possible, appearing in a time when galaxies themselves were barely taking shape. How could such a massive star exist so early? How did it live, die, and explode, producing elements heavier than hydrogen and helium, at a point when the universe was still so young? James Webb captured this event not in visible light, but in infrared, allowing astronomers to peer through cosmic dust that would have obscured the explosion from older telescopes. The details are breathtaking. The glow of iron, oxygen, and carbon, the very materials that form planets and life, streams from the remnants, telling a story older than anything we have seen before. Each photon is a messenger from the dawn of time, whispering secrets about star formation, cosmic chemistry, and the early life cycle of galaxies. What makes this supernova even more extraordinary is how it challenges existing models. Conventional theories suggested that massive stars needed time to form, evolve, and die, and that the first generations of stars, the so-called population 3 stars, would leave behind simpler signatures. Yet Webb's observations reveal heavy elements in a universe far younger than anticipated. It's as if this star was a prodigy, burning bright, dying fast, and rewriting the rules of cosmic evolution. This discovery forces astronomers to ask uncomfortable questions. Have we underestimated how quickly the universe could form stars and galaxies? Could there be other ancient supernovae, hidden in plain sight, that will further challenge our understanding? James Webb isn't just confirming theories. It is shaking the foundations of what we thought we knew about the first billion years of existence. The supernova's light is more than a scientific curiosity, it's a bridge to the past. By studying it, we gain insight into the processes that created the first galaxies, the first planets, and eventually, the conditions that allowed life to emerge. This single star, long dead, now illuminates the origins of everything we see today. It's a cosmic time capsule, and James Webb is the key to unlocking it. And yet, this discovery is only the beginning. As Webb continues its survey of the universe, it will undoubtedly uncover more anomalies, more ancient supernovae, more galaxies that defy expectation, more evidence that the early universe was far stranger and more complex than we imagined. If one star can challenge our cosmic timeline, what other secrets lie waiting in the vast darkness? If one supernova can upend our understanding of cosmic history, imagine what an entire population of such stars could reveal. The James Webb Space Telescope is uncovering a universe that is far more dynamic, turbulent, and surprisingly mature in its earliest moments than we ever imagined. Galaxies appear larger, more structured, and richer in heavy elements than models predicted. The timeline of star formation is accelerating before our very eyes. The early universe, once thought to be a slow, simple place, is now revealed as a bustling nursery of creation. Webb's deep field surveys capture galaxies forming stars at staggering rates, sometimes producing hundreds of stars per year, in an epoch when the universe was less than 1 billion years old. Some galaxies appear massive and evolved, their light reaching us as it was mere hundreds of millions of years after the Big Bang. These observations force scientists to reconsider how quickly matter coalesced, how galaxies merged, and how early supernovae enriched the cosmos with the elements of life. Even the concept of first light is evolving. Previously, astronomers believed the first stars would be small, short-lived, and metal-free. Webb is showing hints of surprisingly massive stars, some of which lived fast and died young, leaving behind the very elements necessary for subsequent generations of stars and planets. It's a cycle of cosmic alchemy unfolding on a scale we are only beginning to comprehend. But it isn't just about what Webb sees, it's how it sees it. The telescope's combination of infrared vision, high-resolution imaging, and spectroscopy allows us to measure not only distances, but also the composition, temperature, and motion of early galaxies. We are, for the first time, tracing the chemical evolution of the universe from its earliest moments. The supernova we observed is a single, shining example of this process, a star whose life and death produced the raw materials that would eventually form planets, oceans, and even life itself. These discoveries are rewriting textbooks. The universe isn't a slow, orderly progression from simple to complex. It is a frenetic, often chaotic arena, where massive stars ignite, explode, and seed galaxies with heavy elements far earlier than expected. James Webb is giving us the proof. Each observation challenges long-held assumptions and opens new questions. How did the first galaxies assemble so quickly? What processes governed the formation of the earliest stars? How did the cosmic web of matter evolve under these extreme conditions? And the implications extend beyond astronomy. By understanding the universe's early development, we gain perspective on our own existence. The atoms in your body, the iron in your blood, the calcium in your bones, all were forged in stars that lived and died long before Earth even existed. James Webb's discoveries connect us directly to that ancient, violent, yet beautiful cosmic story. As we continue to probe deeper, each image becomes both a revelation and a riddle. The ancient supernova was only the beginning. Webb is uncovering galaxies, stars, and cosmic events that defy expectation, stretching the limits of human imagination. If the early universe was this surprising, what other secrets have remained hidden for 13 billion years, waiting for us to find them?
Looking up at the night sky has always been an exercise in humility. The James Webb Space Telescope takes that feeling to an entirely new level. We are no longer merely observers. We are witnesses to the universe's earliest moments, peering across billions of years of cosmic history. Each discovery, from distant galaxies to ancient supernovae, is a reminder that humanity is part of a vast, unfolding story far larger than ourselves. The implications of Webb's discoveries go beyond astrophysics. By revealing how galaxies, stars, and planets formed, the telescope offers clues about the conditions necessary for life. When we detect the chemical fingerprints of oxygen, carbon, and water in distant exoplanet atmospheres, we confront the tantalizing possibility that life exists elsewhere. We begin to see that Earth is not an isolated miracle, but part of a universe teeming with potential. James Webb also changes how we approach exploration. Its success demonstrates the power of international collaboration, with NASA, the European Space Agency, and the Canadian Space Agency working together on an unprecedented scale. It shows that the most ambitious questions about origins, existence, and the future require collective effort, patience, and ingenuity. Every image Webb sends back validates decades of investment in science and technology, inspiring a new generation of explorers, engineers, and dreamers. Perhaps most profoundly, Webb forces us to rethink our place in time. That ancient supernova, exploding billions of years ago, reminds us that the universe has a history far deeper than human history. It challenges the idea that our world is the center of everything. Instead, we are part of an ongoing cosmic story, one in which stars are born and die, galaxies collide and merge, and matter continually evolves. Our atoms, our very existence, are the legacy of events that happened long before Earth was even a concept. And yet, there is hope and excitement in this perspective. Understanding the universe doesn't make us insignificant. It connects us to a story of creation, destruction, and renewal on a grand scale. Each discovery from Webb inspires wonder, curiosity, and a sense of shared destiny. It reminds us that exploration is not merely about finding answers. It is about asking bigger, deeper questions. The future of space exploration is brighter because of James Webb. Its findings will guide future missions, from studying potentially habitable exoplanets to sending probes deeper into the solar system and beyond. Webb is not just a telescope. It is a compass pointing toward the unknown, urging humanity to continue seeking, discovering, and dreaming. In the end, the telescope teaches us something profound. The universe is alive with stories waiting to be told. And as long as we have the curiosity, courage, and technology to look, there will always be more to uncover. The ancient supernova, the distant galaxies, and the unseen mysteries remind us that the cosmos is not static. It is a living, evolving expanse, and we are privileged to witness it.